I want to tell a story of a book that Julian and Allwood and myself wrote 2 years ago. It's not a plug because it's freely available if you want to download it. And I particularly want to look at what the business case is for using less materials. So just setting the scene, Piers this morning in the talk talked about how we take, we make, and we dispose. And we've got a very linear economy that takes materials and high-grade energy and makes that into products and goods and services that people want. And our problem, as we've been hearing, is we have these environmental problems that are stressing the planet, particularly carbon emissions, greenhouse gas emissions. And I guess the challenge of resource efficiency is to deliver these goods and services at some level, maybe a reduced level, maybe the same level, but with using less energy and materials. So where do our energy and emissions get used? Well, basically a third of our emissions come from buildings. That's the use of buildings. A third comes from transport. That's the moving of things, people and things in vehicles. And a third comes from making the buildings, the vehicles, and the products and the equipment that we want. And this afternoon I'm going to focus on this industry perspective, but through the whole supply chain, so from making these products to who actually uses them. So what do I mean by sustainable materials? So firstly, I don't mean furniture made from reclaimed plastic, which is a very, very niche product, let me tell you. I'm not meaning new materials that have been made or dreamed up by scientists. So carbon nanotubes is an example, great things to be looking at, but we make 100,000 times as much steel as we make nanomaterial. And I'm not talking about plastic carrier bags, which is a favourite topic in the UK, happen to be the most efficient carrying device that we've ever invented. They carry about 1,000 times their weight, and also are completely irrelevant in terms of carbon emissions. So 1/100th of 1% of the UK's carbon emissions come from plastic bags, and yet that's what we focus on in the UK. So what are we talking about? Well, we're talking about materials that we use at scale. So 5 key materials make up more than half of our carbon emissions. That's steel, cement, paper, plastics, and aluminium. To put that into context, steel and concrete or cement alone is 1/5 of our emissions globally, which is more than all passenger transport. And we hear a lot about solutions for passenger transport, electric cars, etc., but we don't hear much about steel and concrete, 20% of our emissions. The other problem is the use of these materials has grown rapidly, so 4 to 6 times over the last 50 years. So we're rapidly increasing, expected to double by 2050, these materials. And so if we want a 50% reduction in carbon emissions, we're now looking at a 75% reduction in emissions per tonne of material if we're doubling the amount of material that we're buying. We had a hunch that the answer might not be just in making the processes that make these materials more efficient, but making the use of materials more efficient as well. So we went about gathering evidence because it's very difficult to tell the steel industry they should sell less steel. So this is where we use steel. I'm going to focus mainly on steel just because of the time. 1 billion tonnes of steel a year, that's 200 kilograms per person on the planet every year that we use. About half is in construction, and the rest is spread between equipment, goods, and vehicles. We went about trying to map that. These are complicated diagrams, and I don't expect you to understand them all, but the thickness of the line relates to the amount of steel that we're making or using, and essentially on the right-hand side, have we got a pointer? Yeah. We make steel from ore here, we make steel from scrap here, we then cast, form, and fabricate that steel into some products at the end here. And what's interesting is along this process, these grey lines coming down are the scrap that industry makes. And it turns out that a quarter of all our steel never makes it into a product, and nearly half of all aluminium. And also interesting is that scrap is more than half of the total scrap that we then remelt. So our kind of consumer recycling is not the big story, it's the industry recycling that's the big story. Where do we use energy? Well, mostly in making the steel up here, in remelting scrap, and in rolling here. But if you think of energy as embedded in these materials, so when you make these materials, then if later down the supply chain we cut bits of steel off, we're wasting that embedded energy. And that was one of the key kind of conclusions of the work. We looked at what industry was doing already. So with one eye open, industry is very efficient. We think we can only get about 10 to 20% more efficient because they already spend a third of their money on energy costs. We looked at recycling. We currently recycle about 80% of steel, so we bumped that up to 90%, which is thought to be the limit. We looked at all of the new types of novel processes. This is the Hysana plant in Netherlands that Tata Steel's opening in May, to see what effect they might have. And we also considered a number of renewables, nuclear, CCS options at the scale we think could actually be deployed by 2050. And if we do all of that perfectly in the world, we can reduce our emissions to about half per tonne, which is a huge achievement. But if we double our demand, we get no absolute reduction, which is exactly what Edgar was talking about, a rebound effect, essentially. So what could we do with both eyes open? We came up with 6 strategies for being more material efficient. The first one is lightweighting, and this is the Olympic velodrome. It has a carbon footprint that's half of the aquatics centre, the swimming centre at the Olympics. And the big difference was that the first document describing these projects, the aquatics said iconic building, and the velodrome said lightweight building. And ironically, the velodrome has become the iconic building of the Olympics. Sheet metal is cut. So when we cut up sheet metal to make a car, we dispose of lots of the material. And generally, the sheet metal industry cuts one product from its sheet of metal, wasting a lot because it doesn't tessellate, hence the circles and the hexagons. But if you were to cut a number of different products from the same sheet, like we do for fabrics in the textile industry, you would waste a lot less of that material. If you can't stop the waste, so milling is a product, this is milled scrap aluminium up here. If you can't stop this, there are other solutions. So we've created a process that converts this scrap aluminium into these tubes without melting. It turns out if you extrude aluminium chip, it will rebond and crack the oxide layer and reform into perfectly good products. And we're trying to put some of this product on one of the latest Jaguar cars. What else could we do? We could reuse rather than recycling, and that saves the melting of this steel. And we found a number of kind of niche companies in the UK doing this type of work. This is a company called Portal Power that takes portal frame buildings, sheds, and takes them down, repaints them, and puts them up in other places. And we think there's a good opportunity to scale this because beams aren't damaged in buildings at all. We could make longer life products, and that spreads the impact. Here's a building from London, 1950s building, which they were going to demolish, which instead they renovated. It cost about the same to do, but it was 80% less carbon emissions. And the main driver for doing it was actually because it's difficult to demolish a building in London because of the interruption to the traffic around it. And we could reduce our final demand by using our products more intensively. So maybe, car sharing, maybe working from home where you use your building as a sleeping space and a social space and a workspace. Those types of ideas where we might be able to use our materials more efficiently. if we look at the overall picture now, and those 6 strategies, so here we've got reusing old steel, diverting scrap, reducing scrap, and these ones reduce our overall demand for steel. And if we apply them across the whole spectrum, and here I'm applying them at about half of what we think their potential, their practical potential is. We think that with that and the process efficiency that we saw before, we could maybe get to a 50% reduction in emissions, and that would be great. And I guess we're not saying that one is better than the other. We're just saying that we should be looking at all these options, because industry won't look at the options where you're reducing the demand for materials. We'd like to look at options where we can reduce these demands. The book that we've produced, it's available for free to download from www.withbotheyes.open.com. And if you want to download it, I recommend to have a read. In there, we've gone a lot more into the business case. We went a lot and talked to a lot of different businesses. We've got a consortium of 30 companies and tried to work out where that might work. So, for example, Tata Steel, company that we work with, is quite interested in whether, instead of selling bulk steel, so tubes and sheets and beams, where they want to sell more of that, it's profitable to sell more, maybe they could sell a building frame system, a final service, where they could then reduce the amount of steel in there and make it more profitable and sell it for more money. Jaguar, we try and convince Jaguar to do a lifetime lease car. They are not buying it, but the idea of driving around an E-Type Jaguar with a modern engine and modern brakes and a good stereo is interesting. And the idea of having a car that you live with and you take it back every 5 years and you can have the paint color changed or upgrade certain parts of it might be a model that they could do. Thank you.